this has become my kind of therapy session. Maybe 30 minutes a day of just checking out some Ramda functions. So anyway, this is your first time here. This is Pipe Dreams Season 2, a Ramda Deep Dive, follow up to a previous series that was abandoned 7 years ago. And I've been, I mean to approach these functions for the first time while I'm recording, but I looked ahead. And some cool ones in here, one or two that are a little bit tough, but we are, oh, sorry, I'm trying to close the sidebar. Here we go. Um, we're going to start with includes, except we've already done includes. That was done uh, during Chris's original series when we looked at any. It said see also includes, but just a real quick one because or real quick recap since it's so simple. It takes a thing and then it checks if that thing is in a list. So a thing, a list, and is the thing in the list. It's Ramda's version of the includes function that's on the array prototype in JavaScript. Returns true if it's equals. The only caveat is the cool Ramda thing where r dot equals if we have a one x1 and obj2 are they equal? True, they're equal. Even though JavaScript checks equality by reference, using the equals function, it is true. If we just did this, it would be false. And even if you use that lesser known object.is, one, object two, it is still false. So, look at the example here. R dot includes three. That's the thing. Here's the array. Is it in the array? Yes, it's right there. So it's true. Four is not in the array, so it's false. And then this object name, Fred, is in the array name Fred. Uh, yeah, that's includes. So let's check out index by. And we actually looked at that one, right? I can't remember when we looked at group by. I feel like we did not. So let's take a look at it. It is similar to group by, obviously, because it says see also group by. Um, we have a type constraint. The A in this type signature is an index, and an index is either a string, an int, or a symbol. But as we've seen before, when this happens, it's usually because we're going to be using the A in an object, and in JavaScript objects, the keys are strings. So I think it's almost always going to be a string, but obviously there's a reason it could be one of these three. Um, Given a function that generates a key, so that would be this function here, takes a B and generates an A, and we know an A is the key in this object. It turns a list of objects into an object indexing, turns a list of objects into an object indexing the objects by the given key. Let me read that again from the start without interrupting myself. The index by, given a function that generates a key, turns a list of objects into an object indexing the objects by the given key. Um, so before we go any farther, let's take a look at that. Let's do a log r.index by, and it takes a function. So it's hard to think of an example where we don't use the prop function as the function we're passing to it. So I'm just going to use that. Uh, but we haven't seen that one, so let me just write it out. I'll make my own prop. We're going to take a object and we're going to return, sorry, we're going to take a prop, I'm going to curry it, and then an object, and then we're going to return the value for that prop in the object like this. Um, but I prefer to do it like, well, that's good enough. We'll just do that. We'll get into more about prop when we get to the P's. So index, then we're going to pass in the prop, and it's going to take the ID because we're going to use, no, we're going to take in the title because we're going to use this post here as our object. I'll pass it all at once inside one set of parentheses in this case for no reason. And we get an error, probably because of my prop. List must be an array or an iterable. Oh yeah, okay. Wait. So we take the function and then we take the list of B's. Oh, I said object. I should say posts. Sorry. Maybe it's a little too late to record videos. We'll see. So this is what it does. It takes the we take the title prop, right? And it returns the value for the title. So if we on this iteration it gives us post one, in this iteration it gives us hello world, this one it gives us post three. And then what it does is it makes an object where the thing that we just pull out, the title, but the value of the title is the key. And then the whole object is the value. So it's really handy because it allows you to look up these posts by the post title instead of using a function that says like, uh, a function that says find something based on something, then you've got a callback. This is just much more straightforward um, because once I do that, if I said const posts by title, then I could just do like uh, post by title, and then use this syntax and said like if I wanted hello world, I would just pass that as a string and just get that one back. Let me clear my log. Just get that one post back. It makes looking up really simple. So that's what it means by index. Very similar to group by. Let's go check that out again. And let's see what they're using. Group by, they're just getting the score here. And then well, here, let's look at the function. Splits a list into sublist. Yeah. So they're grouping everything by the key. Um, because here you've got like a range, like anybody under 65, you're going to use an F. So these are the keys, a key generating function. That's really all there is to both group by and index by, is you just got to think about the key generating function. What keys do you want to generate that are going to be on the left side here? And then on the right side is going to be all the objects that match it. But in this case, it groups them. So it's like an array of objects. And the index by, it's not a group of objects, it's just one object. And I'll keep reading. There's more info there. Note that if multiple objects generate the same value for the indexing key, meaning like, I'll put this one down here, made a copy of post one. And let's see, note that if the multiple objects generate the same value for the indexing key, yeah, that should be the same thing. Generate the same value, only the last value will be included in the object. So yeah, let's change this to 4, but we'll leave the post the same. And this is the scenario they're talking about, I think. Let's go back here and just log the function here. What did I do? I'm trying to erase that. All right. So let's log that. And so we got post ID 4, 2, and 3. It skipped 1 because we're getting the title, and the title is post 1 for each. So since we're not grouping them, we're just indexing each one like a flat object. Um, the last one wins if there's duplicates. But in group by, it would just group them together, I think. Why don't we just try it? Yeah. So here, post one, we have two things, and it's an array. And then the second thing is just indexed. So I think that's really the only difference. And if we look at the type signature, um, the B to A function, so the key generating function, the list, and then the object AB. And if we look at this one, key generating function, the list, and AB. So it's the same function signature, isn't it? That's slightly different. Oh, okay, yeah. So the only difference is that an index by, you just get a flat object. A's maps to B. Here it's A maps to a list of B's. But it looked like this is a list, but this is not a list. Hard to see because I'm zoomed in so much. Let me just zoom out one. That's better. Yeah, that's an array. Oh no, they're all arrays. Yeah, so an array with one item or an array with two. So I'm glad we looked at that. Let me clean up just a little bit. Okay, so it acts as a transducer if a transformer is given in list position. I've already mentioned that we're going to skip that. Um, but we do get into needing to know what a transducer is soon, but not quite yet. And I'm just going to move on. Um, that didn't take too long. That was a list. Here's another one, index of, that we've looked at. We looked at it when we looked at find index. So it's another one of these array prototype methods, just Randa's version. Uh, yeah, takes we want to know in the array, what is the index of 3? And we go 0, 1, 2, and that's what it is. And 10 returns -1 because it's not in the array. So we're going to skip that one. and we're going to skip a knit because we just did that one. I think maybe even the last video. It's just all of the array items except for the last one. The opposite of tail, where tail is all of the elements except for the first one. And then head is the first one, last is the last one. That's all there is to that one. But then we get into inner join, and this is a cool one. This is actually surprisingly useful in the real world for me, where for my job I will very often have two lists of email addresses, and I need to know which email addresses are common to both lists, um, or something like that. That's not what this does, though. Um, what this does, if we look at it, is one of these set theory things. And I'm not going to go open up Wikipedia and look at the set. I think it's easy enough to visualize in your head. It's a relation. Uh, I don't know what to call it. Is this a category or a tag or what? But it's grouped as one of the relation functions in Ramda, like greater than or less than or something. Um, if we look at the function signature, it's taking an A and a B and returning a Boolean. So when a function returns a Boolean, we call it a predicate. And uh, then we have a list of A's and a list of B's, and it returns a list of A's. So since the predicate function takes an A and a B, and we're doing an inner join, we're comparing two lists, it's logical to assume that this A means something from this list and B something from this list so that the comparison can happen. Uh, and it says we takes a predicate, a list of X's and a list of Y's, and returns a list of X's prime. That's how you pronounce that um, little apostrophe, I guess it would be called. Uh, they use that in Haskell a lot, but basically it's a naming standard or convention for when you want to reuse the word or the variable x's. It's not these x's, it's just like an updated version of x's. So we're going to call it x's prime. So this takes the predicate, a list of x's, a list of y's, and returns a list x's prime, comprising each of the elements of x's, which is equal to one or more elements of y's according to the predicate. So the predicate is going to determine our equality. And this is just a fancy list of saying we've got this list of x's here, this list of A, and this B is the y's, and this is the x's prime. What we're saying is that given a list of x's and a list of y's, show me which x's also have y's, right? So it's not like which ones are common to both. It's using this as the main list, and this is the list it compares with. And as long as the items are in both, then it goes into this list. But it doesn't care if the B's are in the A. Like it's not looking in that direction. It's just looking at the A's. So did I have a had some X's here? Let's make some Y's. Bring these down here. Let's just change this up. 16, 17, 42. And so let's say let's just keep it vague right now to call them X's and Y's, but we're going to take our inner join and we need the function and two lists. So that's going to be the function and the X's and the Y's. So for our function, why don't we just use equals? trying to think, that's not going to work because this function takes an A and a B. Try it. Let's see what'll happen. So first of all, did it do what we thought it would do? We got a 1, 2, 3, 5, and 8. So that would be the numbers from this list, where each number also appears at least once down here. The 1 does, 2 does, and 3 does. 32 does not. 5 does, and there's 5. These two numbers don't match. These two don't, but 8 do. So it does work like this. Um, yeah, I guess since equals is, I mean, it's automatically curried, but you can still pass it, X and Y, if you had, or sorry, X and Y, because it's checking each number, one number from this list, and I don't think it checked just, like the first number and the first number, like I was doing it just a second ago. It looks at this number and then it checks if any of these numbers are the same. And if it is, it goes into our output. And then two checks 1, 2, 3, 4, 5. So I was just lining them up and checking them because they were generally in the same order. So yeah, that works. We can pass it that way. If we had to call the function like this, that would not have worked, I don't think. But we're doing it point free. We don't have any x's and y's to pass around. Um, so it's equals continuous. So what do they do? So they get a record. Let's check out their example. That's kind of cool. I'm finding with Ramda that sometimes, because of how precise they try to make the definition, it's hard to understand it. Like we're programmers. We don't read definitions. We read code and then reverse engineer it. And it's almost easier to do that and then read the description. And then the description like helps you fine tune the details and be precise about what's going on. Uh, so if we run this code, we get two things. So what we're doing here is even though this list is just an array of numbers and this list is an array of objects, we're using this function here. It's not just checking is something equal to equal. It's grabbing the ID property out of this list. So like these values and checking it against the ID. That's the second argument here against this. So it's doing like more than just straight comparison. It's doing like a little operation first to get a value and then compare that value. Um, so again, you might have like a database of customers with overdue balances, sorry, uh, maybe just a list of all your customers, right? And then your boss gives you um, some customer IDs, just a list of customer IDs, and you want to be able to find the objects, um, or find the customer record so that you can pull out their email address and email them and be like, hey, you got to pay me. Uh, yeah, so again, another a pretty usual one. And it gets hard for me to remember which was which. Like there's inner joins, there's intersection, which we'll look at. There's difference, there's union, and then there's slightly different terminology between different libraries. So anytime I do need to do something like this, I find myself just looking it up. It used to be Stack Overflow, and then now it's ChatGTP. Um, if anybody's got some sort of like cool way to remember which function does which with these set functions, uh, drop a note in the comment. And as I just said, set, we're dealing with an array, but in both examples, everything was unique. And so an array of unique elements is a set. So I wonder what happens if we have duplicate elements. Let's try that. And actually, I think it mentioned something in here. So let's finish reading the description first. I'm kind of bouncing all over the place, but we've been doing a lot of these, so I don't think we need to do this formally. Um, okay, so it takes a predicate and a list of x's and y's and returns a list x's prime compared comprising each of the elements of x's, which is equal to one or more of the elements in the y's according to the predicate. So again, uh, look for the things in A that are also in B and give me a new list of those. Predicate must be a binary function expecting an element from each list. So yeah, that's just saying that as we're running this, we're going to take an element from this list and an element from this list and compare them. But it's not like it compares just the first one with the first one. You know, that wouldn't work because we have what, six of these and three of these. Um, so yeah, x's, y's, and x's prime are treated as sets semantically, so ordering should not be significant, right? So when I read that the other day, I was pretty confused, but it's what I was just saying. Um, Even though you could have duplicates, semantically, it doesn't matter because we're just asking for a list of objects inside here and here. I feel like there's no reason to mention this in in the documentation, and it just makes it a little bit more complicated to understand. But there must be some special case where you need to know that. Um, and it says the order of implementation guarantees that its values are in the same order as they appear in X's. So if you do have duplicates, it's going to be in the order that they appear here, even though we're dealing with objects. Um, yeah, because these objects are in an array, and an array automatically indexes each object. You know, an array is literally an object where you don't come up with the keys. The keys are generated for you. 0, 1, 2, 3, 4, 5, and then there'll be a length property on the object or on the array. Uh, but that's just a side note. Duplicates are not removed, so x's prime may contain duplicates if x's contain duplicates. So yeah, I duplicated this, and let's change Fourier to furry, and let's put 824 in the Y's. Check if that one exists. Yeah. And then so we get these duplicate objects. In fact, what if they were like literally the same? We would just get the same thing. Yeah, we get them both. Because it's saying like, okay, here's 824 because we're pulling out the record ID. And then it says, is 824 anywhere in this list? And it says yes. And then it asks the same question again. It doesn't care if this one was in there or not. So that's why I'm saying it can include duplicates. So let's just go and check out intersection 2 because it says C also. And super simple type signature takes two lists and returns another list. And the list can contain anything. And it says it combines two lists into a set, meaning a list, an array with no duplicates, composed of those elements common to both lists. So this is what I was saying earlier. And the first one, inner join, is only concerned about creating a list of x's that are also in the y's. Um, this one returns a list composed of elements that are common to both, so that are in both. So let's go back and use r dot equals. That's simple. And I sent x's and y's, but we'll change the function name to intersection. We get nothing. Combines the two lists into a set composed of those. Oh, I'm sorry. This one doesn't take a function. I mean, I just said here's the takes the x's and y's. Let's go one liner. All right. So let's before we run it, let's run it in our heads. A list of elements where they're both in both. So we're going to get 1, 2, 3, 5, and 8. Right. So that's the same as the first example because we were doing equals. So by using equals, we were essentially making an intersection function out of inner join. That's interesting. I didn't think about that as I was doing it. 1, 2, 3, 5, 8. Yeah. Um, I mean, and that's all we can do. So it's like really just the, yeah, we provide two things and it gives us the common things to both. And I mean, that's simple. Like if you have people, a list of students in a bunch of classes or in two classes, and you want to see which students are in both classes, that's intersection. And again, that's definitely straight up set theory. Um, and some of these functions are included on the set, uh, I should say, an instance method of the set object in JavaScript, which came out in like 21 or 20 or something, 2020, 2021. Um, and then I think in 2024, they released a bunch of instance methods like these. So some of these may exist in JavaScript. Definitely, it existed here before it was built into JavaScript. This is in version 0.1. Um, and I'm going to do one more because the one after this is a doozy. So you can always pause if it's too long. Um, and it's called intersperse. And it's very simple. It takes a thing and a list and returns another list. And they are all of the same type. And what it does is it creates a new list with the separator interposed between the elements. Um, and then this random thing that we're going to ignore right here. So if I said intersperse, and it's going to take something and then an array. And what it's going to do is it's going to just put the thing, the first argument, in between each element of the array. So the best thing I could think of right now is to put a taco in it, right? If you put a taco in between any two things, it makes those two things better. That's just the mathematical law of tacos. That's what we do. One taco, two taco, three taco, 32 taco. Um, and, this, what it looks like to me is it reminds me of the join method for arrays, where you can like join by like a dash or a space or a comma or something. But that turns it into a string. We're doing the same thing, but we keep it as an array. So like you could do, leave this one. And this one's cool for partial application. We could just say insert tacos and to r dot intersperse and serve up a taco. Does this sometimes. There we go. Weird Mac stuff. Um, and then we could just say insert tacos, insert tacos, and just pass it the list. So this would be basically like formatting a list based on something. Maybe you needed to, you want to put like a little bullet point or something. I don't know. You come up with your own use cases. R dot insert tacos is not a function. Well, it should be because intersperse takes an A and a list. Like not save it or something. Yes, that's saying undefined. Oh, R dot. It's not R dot. It's my own function. Yeah. And you get the same thing. And then you could also do like R dot pipe. And then we could say R dot join. I'm trying to open up my yeah, something's happening. Probably need to restart my computer one of these days. Uh, but if we did that much, and then we did R dot split on like nothing, and then we need to pass it. In fact, we could do R dot flow and just pass it to X's right up front. Oh, but when we do a pipe, we have to put the callback functions in uh, parentheses as a list. It's like two arguments. The second argument is a list. I forget that sometimes. Interesting. R dot join, passing in a list of X's, and joining the list with the taco. It's giving me a string, and I'm splitting the string. Let me not get fancy and just do a dash. Did this the other day, and even the point, if I get it working, it shows you where it's still not the same thing as intersperse because it only works in certain scenarios. But now I want to figure out like how would I do take an array, add something in between, and then end up with an array. Oh, I mean, that's exactly what I got. It just looked funny. And I guess there's something to do with emojis. Just trying to be cute. But see here, the problem is I passed it an array of numbers. And when I join it with the dash or intersperse the dash, um, and then I can and then I split it again. Like when I intersperse it or join it, it becomes a string. And then when I split it, it's an array, but the numbers are um, strings now. And so then I would have to like map over this and then check if it's like can be a number, and then use like the number thing. I just do it since I started talking about it. And since Randa makes this stuff so easy, um, I would need to take the X. I'm going to use multiple lines for a second to read it. So we need to check if the X, if I do number X, I'm going to return this. Yeah, see, then I get a not a number. So then I have to check if it is a number, and or like if it's not a number, you know, uh, to find out these other ones. So you might think like, oh, we could just do this ourselves with something like this, but there's always a little thing. So if you need to intersperse elements into an array, but return an array, this is your weapon of choice. It's pretty simple. So I think I'm going to end it here, and then we're going to get into. I didn't mean it to be like that, but into. And if we look here, we've got into, invert object, and invoker. These two, invert and invert object, are pretty similar. Um, and then we get into a bunch of these little predicate functions. Um, and then we'll be done with the eyes, and that'll be another milestone. So I hope there's something useful in this video for you, but thank you for spending your time with me. Tell a friend, and I'll see you in the next video.